Welcome to Learning Chemistry with Faye. In this video, we'll learn how to determine concentration of solutions, and we'll progress to perform dilution calculations. So let's first look at what is concentration of a solution in an example. So in this example, we want to determine the concentration of a solution that contains 32.082 grams of copper sulfate, which is dissolved in a 0.2500 liters of solution. So what is concentration? Concentration is symbolized by molarity, which is the big capital M in chemistry world. Okay, so what is concentration or molarity? It is, we wanted to calculate how much in mole numbers of your solute in the volume of your entire solution. So what is the existence in the units of a mole of your solute in the entire volume of your entire solution? Okay, so it's moles per liter. That's what you needed to remember. Molarity equals the unit of moles per liter. So once we know that, we already know how to determine mole numbers from a particular weight. So in this case, we were given a weight, which is 32.082 grams of copper sulfate. So what we need to do is we needed to convert this particular weight into a mole number. So of course, we're going to start with our given, and then we're going to divide this by our atomic weight or by our molecular weight of copper sulfate, which is 159.61 grams per mole. And that will give us the mole number of copper sulfate. So in this case, we have 0.2010 moles. Remember to keep all your sig figs. Okay, so in here, actually, we kept 4. We should have kept 5. All right. But the reason being I'm keeping 4 here is because if you look up in your solution volume, we have 0.2500 liters, which is a 4-digit number. So we only need to keep 4 over here. But in your calculations, remember, carry 5 at all your steps, carry the correct sig figs at all your steps until the very last step. Okay, so once we have the mole numbers of our solute, we're going to divide that by our solution volume, which is in liters. Remember, the standard units for molarity is moles per liter. So if your liter was given in any other volume, such as milliliters or centimeter cube, you have to convert it to liter before you can move on. All right. So in here, after we have our moles per liter, we get 0.8040 moles per liter. And then we can further change this particular unit back into our big M, symbols as concentration, which is molarity. Now let's look at another example. Actually, still with the same example, that we're going to put what we have just calculated into practice. So we're going to try to imagine that we're in the lab and walk step by step of how to make the solution. All right, so first we're going to start with the copper sulfate, and we're going to go with, okay, first we're going to weigh it on the analytical balance. So remember, whenever you do measure any type of solids on the analytical balance, do not change the significant digits on it. So if your analytical balance says it's 3 digits after the decimal, simply copy it down. If it's 4, just write 4 digits down. Don't change it, okay? So after that, we are going to dissolve it in 250 milliliters of water. So we're going to get a flask, right? So we don't want it to make any solutions in a beaker. We can get a tall neck flask, or actually just a regular flask would also do. And we are going to put 250 milliliters of water in it. Then we're going to also drop the solid in and try to dissolve it. So after you give it a little mix it really well, now you actually have a solution. But remember, whenever you're first wanted to do 250 milliliters, you don't put it up to the line. Okay, so let me give a quick hinter here. So first, whenever we pour in water, we just pour in just enough to dissolve all the solids, but not up to this actual mark. And then we will bring everything up to the 250 milliliter mark after we dissolve everything and make sure there is no crystals or there's no solids at the bottom of your flask. And that is bring the total, including the 32 grams of your solids with the liquid to 250 milliliter mark. If you bring it to the 250 milliliter mark too early, once you add the solids, it's going to actually go over. And you also don't want to shake or mix while your water is too tall at the neck of your flask. So now we have calculated the concentration of our particular solution. We have made our solution in a laboratory kind of setup. Okay, so now we have 250 milliliter of this concentrated copper sulfate solution. Now what we wanted to do, we wanted to take out 15 milliliters of it, which is called a 15 mil aliquot. It means you are using a pipette, taking out 15 milliliters of it. And then we want to calculate how many moles of this substance, just your solute, is inside in this 15 milliliter portion of your solution. So what we'll do, of course, we're going to start with our given. We're going to start with the 15 milliliters of solution. And the next thing we need to do is we need to convert this into liters. So that means we need to divide it by 1,000 milliliter, right? So first thing that we need to do is we need to convert the volume to the standard volume into liters. And after that, now we have the volume in liters. We're going to remember that our concentration is each liter has the concentration of 0.8040 moles of copper sulfate. So out of the 1 liter, now we multiplied it by the 15 milliliter of this particular mole, and then you will have the mole numbers for this 15 milliliter aliquot, which gives us a 0.01206 mole of copper sulfate. So in here, remember, you're still looking at the sig figs, which is, remember, 15.00 is a 4 sig fig number. 1 liter equal to 1,000 milliliter is a standard conversion, which does not take into account, it's a precise number, right? So it's not a, doesn't take into account of your significant digits. So, and then you are looking at the mole number, and of course, that brings us to the 4 sig fig answer. Remember all the zeros before your decimals, and the zeros before your actual number after the decimal does not count as a significant digits. Continue on with the same solution, but with a different known, and we're looking for a different unknown. So earlier we were given a particular volume. I wanted to know how much solute we're going to have if given that particular volume. Now we're going to switch roles, and we are going to look for the volume while given a particular solute weight. So of course we always start with the given, and then we're going to start with a 6.145 grams of copper sulfate, and we're looking for the volume of the solution that is needed to provide this particular weight of the solute. Right, so that means we need a mole number to convert anything to do with your solution, right? So we're going to go ahead and convert that with each mole of copper sulfate gives the molecular weight of 159.61 grams. So after you cancel out the grams in units, you have the mole number. Now with that mole number, remember, The next one, you are converting it to the volume. Remember your concentration that was given, even though it's also written in molarity, but remember molarity also have the unit is equivalent to the units of moles per liter. So we're going to write that down as every liter of your solution would give us 0.8040 moles of your solute. And now you will get the answer in volume in liters. And that's equivalent to 0.04789 liters of your solution. So that means in this case, if you want to end up with 6.145 grams of your solute, you will need about 47.89 milliliters of your solution. Now let's dig a little deeper about the particular molecule that we're talking about. So we just made a solution with a particular solute. And now what we want to know is what is the total ion concentration in this solution? So what is ion concentration? So all your molecules is made with positive cation, which is called cations, and your negative anions. So each molecule, before you wanted to determine the ion concentration, you have to be able to identify how many ions made up your molecule. So in our case, we have copper as our positive ion, and then we have our sulfate as our negative ion. And then that means each mole of our molecule gives 2 moles of ions. So what we're going to do is we're going to write down the solution concentration and then multiply by the ratio. So each mole, so over here, it's actually given to us as the 1 molarity of our solute gives 2 molarities of ions. You can also, so this way you can cross it off the copper sulfate well. So you can also do is actually do 1 mole of your copper sulfate gives you 2 moles of ion, and just cross off the moles and the copper sulfate separately. All right, so this way now you will know that. So with 0.8040 concentration, okay, molarity of your solute, you will get twice as much of in concentration for your ions. So now we have learned a lot about how to make a solution with a particular wanted volume and concentration of that particular solution, right? So we also learned how to determine a particular weight of our solute according to a volume of our solution and vice versa. So now let's take a look at what happens if I want to make the solution into a different concentration with a different volume, which is called a dilution. Okay, so let's take a look at this. So in this question, we wanted to describe how to use our solution to make a 500 milliliter of a 0.2 moles, 0.2 molarities of our solute solution. Okay, so let's first look at what we need to know. So this time we want to change everything, right? We wanted to go from what we have to something new. And we're going to first remember everything that you need to do. You have to first compare everything in moles. So you can start with the concentration of your new concentration, which is 0.200 molarity, or you can start with your volume. Either way is going to work. So in this case, I'm going to start with our volume, and it's already converted into liters, which is 500 milliliter is 0.5 liters. Okay, and then we're going to multiply it by the molarity, the new molarity, to give me the mole number. Okay, so remember the molarity, you can automatically just switch the units into moles per liter, right? So you can also imagine this if you started with a concentration, you would have these 2 numbers switched, but you would have the exact same outcome, right? So now you would end up with 0.5 multiplied by 0.2, but in the units of moles, because your liters will be crossed off. And now you have 0.100 moles of your solutes needed. And the width given of your solution, you are going to start with a small number and then multiply. But remember, this time, your concentration, you need to write the moles on the bottom. So it's 0.8040 moles on the bottom per liter on the top. Okay, to cross off your mole to give your new volume for the dilution that you're going to use, right? So that means you will need about 0.124 liters of the 0.8040 molarity solution to make 500 milliliters of 0.200 molarity of your copper sulfate new solution, right? So this is how you would use it as your normal calculations to calculate a dilution. Okay, so so imagine you are in the lab, you're going to combine 124 milliliters of your original stock solution and dilute it to 500 milliliters. And then you would have the 0.2 molarity of copper sulfate solution in concentration. Okay. But there is an easier way to do it. It only works for dilution. And let's take a look. So here gives you a quicker way of how you calculate a dilution concentration from a concentrated solution in a much simpler way. All right, so from your concentrated solution to a diluted solution, what you have to do with two concentration given, what you are going to do is you are going to mark the concentrated solution as M1V1, okay? And then the diluted solution, you are going to note it as M2V2. So in our case, we already have the M1. We already have the M2 and V2. We're looking for V1. All right, so in this case, this is where we're going. So for dilution, in general, they are the same mole number. So your mole numbers are the same. So therefore, your M1 multiplied by V1 has to equal to M2 over V2. And all you have to do is identify what is M1 and V1 equals to what is your M2 and V2. Let's look at our question one more time. Okay, now looking at the same question, instead of trying to remember, okay, what do I want to start with? Which piece of a given do I want to start with? You don't have to do that anymore. All you have to do is first write down, okay, I am doing a dilution calculation. So therefore, I'm going to write out my formula as M1V1 equals to M2V2. And now I'm going to identify everything. Okay, so I'm going to identify, first I have a concentration. You can do either to be M1 and V1, but you just have to keep it consistent. Okay, so you can keep the M1, V1 to be the concentrated on one side, or the other, doesn't really matter, but you just have to keep them consistent. So here we go. I'm going to identify our final solution as M1. That means I'm going to identify our final volume as V1. What we have from the stock solution is also concentration. I'm going to identify that as M2. So therefore, now I am looking for V2. Or we can also do it the other way, right? So we can identify the diluted solutions to be M2 and V2, and fill in the concentrated as the M1, and now you're looking for V1. So it's the same outcome, okay? So now we're going to, in our case, since we identified our concentrated stock solution as M2, remember we're looking for V2. Okay, so we're looking for the volume of, basically the volume of our stock solution that we need to pipette into our flask to make the diluted solution. So looking at that, we have just doing some math here. If you're not familiar with how to do this algebra, make sure you let me know, or make sure you get help how to do this steps. So we will give you V2 equals to M1 times V1 divided by M2. And fill in all the numbers. You will cross out the units in concentration and you get the exact same number, exact same outcome as 0.124 liters, which is also equivalent as 124 milliliters. So this is the same as if you wanted to make this diluted 500 milliliters of a 0.2 molarity of your diluted solution, you need 124 milliliters of your stock solution. Now we're going to use everything that we have currently just learned into a question that, let's see, how can we calculate concentration of a solute in a solution from just a given, okay, with something that is totally possible in the real life that we wanted to measure. Okay, so let's look at this. So in this question, we have a sample of Shasta College water has a hardness of 62 ppm, so which means parts per million calcium carbonate by mass. What is the molarity of this solute in this water? So let's always remember to start with our given. So what is our given? Our given is 63 ppm. So remember, this is not a unit of mole or weight, but is a unit of a ratio, which means 63 parts out of 1 million parts. So 63 parts of the solute in 1 million parts of the solution is calcium carbonate. Okay, so let's look at that. Then how do we write this down? So what we wanted to do with the two parts, we're going to convert this percentage. It's kind of like a percentage, except this ratio is in parts per million, okay, instead of parts per 100. We're going to write it as 63 over a million. But we're going to tag along the weights in grams for both parts. So we know that in 63 grams of this solute, we have is in 1 million parts or grams of the Shasta College water. After we have determined what we are going to start with, now we need to look at what we're looking for. We're looking for the molarity of calcium carbonate in this water, right? So that means we want the units to be moles per liter, right? We need to have this units end up to be molarity, which is moles per liter. That means we're going to do two sets of calculations using the same division line. So the top part, the 63 grams of calcium carbonate, we're going to convert that into moles. So therefore, to calculate mole numbers, you guys are all familiar. We're simply just going to divide it by the molecular weight of the calcium carbonate. And then we're going to move on to get the mole number, which is 0.63 moles of calcium carbonate. But the bottom, we don't want it in moles, right? So we wanted to have the units in volume. Therefore, we need liters, right? Remember that molarity is moles per liter. So that means we need to somehow convert this 1 million grams of water into a volume. How do we do that? So we need to use the information of a density, right? Remember, the water density has 1 grams per 1 milliliter. So we simply just going to use that 1 gram per 1 milliliter of water density conversion and change that 1 million grams into a volume. So that means now we have the volume in 1 million milliliters, and we need to further convert that into liters, which is divide that number by 1,000. And now we have everything in liters on the bottom. And with that, now we have the top in moles, bottom in liters, and we can calculate our concentration with the moles per liters for our solution. And that gives us 0.00063 moles per liter, and we can further write that as molarity. And that is our final example for this video, and I hope that have helped you a lot. And Hopefully I will see you in the next video.